Hello Year 10. These are the notes to go along with exercise 6b. The heading is congruent triangles, and then there's a couple of comments. Firstly, you need to know that congruent triangles are the same size and the same shape. And that if they're the same shape, that must mean that their angles are equal, corresponding angles are equal, and that corresponding sides are the same, by which I mean they're the same length. Once you've got those definitions under your belt, the four congruence proofs are these ones. I'd like you to copy them down. Remember that writing something down helps you remember it. Just to help you understand this one, just maybe just a little bit better, let me draw some diagrams that go along with these ones in my head. The first one is a side-side-side triangle. So I try to think of triangles that look exactly the same. And remember, I'm a rubbish drawer, so these are not going to look exactly the same. But the idea is that the bottom sides should be the same. The left-hand sides should be the same. And that the right-hand sides should be the same. And if you've got that picture in your head, that the bottoms are corresponding and the same size, the left-hand sides are corresponding to each other and are the same size, and the right-hand sides are corresponding to each other and are the same size, then you've understood side-side-side. The diagram that goes along in my head with side angle side is to say that I've got two triangles, and I normally imagine them sitting upside down because I'm interested in knowing that they are side angle side. Okay? The left-hand sides of those two triangles are supposed to be the same. The angle that's included between the left and the right is supposed to be the same, so I've marked it with a little angle marker, and then the right-hand sides are the same. They could be different to the left-hand side, so I've used a different number of dashes on the lines, but that's what I mean by side angle side. Two sides and the included angle, the angle in between the two that we know, must be the same. Angle, angle, side. Well, you can tell the diagram I'm going to draw with that one. It's going to be a triangle. I'm going to say that these two triangles should be corresponding, so I imagine them being exactly the same. And I know that two of the angles, two sets of corresponding angles, are equal. So this left-hand angle in both triangles are equal. The right-hand angle might be different to the left-hand one, but it must be the same in both of them. And then a corresponding side. It's not necessarily the size that's in between, the side that's in between the two angles, but it's a corresponding side. So in this case, it's not the one that's in between the two angles, but it's the other one that's hanging off the angles with two arc markers. Okay, so that's a corresponding side. I could also have put markers like little circles, perhaps, on those two sides against their corresponding sides. And if I'd particularly wanted to, I could have put markers on the bottom triangle. But all we're really concerned about is that the two sides that are the same are the corresponding sides placed in the same position to the angles. And then the Pythagoras theorem example. Okay, we're interested in a right angle triangle only. And if we know that we've got two right angle triangles that are the same, mean that they're right angle triangles, that they've got the same hypotenuse. The side opposite the right angle has to be marked the same. You could put the same number on it if you wanted. And one other side. It's got to be a corresponding side. So I've drawn these two triangles with smaller angles on the right-hand side. So those two sides, between the right angle and the smaller angles, are corresponding sides, and they must be the same. So it's right angle hypotenuse and one other side.